Hello everyone, today we will be continuing our discussion of scheduling problems with an overview of directed graphs. Now, directed graphs, or digraphs for short, are essentially just graphs where all of the edges have direction to them. So instead of referring to the edges as edges, we call them arcs. So for instance, in this example down here on the bottom, we have arcs that go from A to B, A to C, and so forth and so on. And when we have arcs like this, say we have an arc that goes from A to B, we would say that A is incident to B, or we would say that B is incident from A. Now, kind of similar to with regular graphs, we can have paths in directed graphs. So, for instance, if we go from A to B to C to F, we've traveled along 3 different arcs. Notice that we have to go in the direction that the arcs are pointing. So we would say that this is a path of length 3. Now, when we have a path that starts and ends at the same vertex, we call this a cycle. So, for example, if we go from C to F to E and then back to C, that would be a cycle, and we've traveled across 3 arcs, so we would say that this is a cycle of length 3. Now, one other concept related to digraphs is what we refer to as the in degree and out degree of a vertex. Now, what this basically is just how many arcs start or end at that vertex. So the in degree is how many arcs end at that vertex, so how many arrows point to it, you could say, versus the out degree is how many arcs start at that vertex, aka how many arrows point away from it. We have all of the vertices for our graph over here, and what we're going to do is we're going to find the in degree and out degree for each of these vertices. So for A, we have no arrows pointing to it, but 2 pointing away from it, so that would mean our in degree is 0 and our out degree is 2. B, we have 1 going each direction, 1 in, 1 out. So we would say in degree 1, out degree 1. C, we have 4 arrows pointing to it and 2 pointing away from it. So we would say our in degree is 4, out degree 2. D, we have 1 of each. So in degree 1, out degree 1. E, we have 1 pointing to it, 2 pointing away from it. So in degree 1, out degree 2. F, we have 1 pointing to it, 2 pointing away from it. So also in degree 1, out degree 2. And then G, we have in degree of 2 because we've got 2 arrows pointing to it, and out degree of 0 because no arrows are pointing away from it. So when we have something like this, like point G, vertex G, where we have an out degree of 0, this basically means that G is kind of a dead end. We can't really have cycles that go through G because once you get to G, you can't leave it. So you're not going to be able to get back to your starting vertex. Same thing with A. You can go away from A, but you can't get back to A, so you can't really have cycles that include A. Now, all of the arcs that are included in a graph, basically the list of all of those is what we refer to as the arc set. Now, one application of directed graphs that we'll be looking at in the next few videos is what we refer to as a project digraph. And this would be like what we have on top here. So essentially what this is a directed graph that shows the relationships or precedence relationships between different tasks. So if we look at this, we would say that A does not have any precedent tasks besides the start, which is what we call a fictitious task. Basically, it's a task that we create with a time of 0 before any of the starting tasks. E, we would say A is precedent to E, E and D are precedent to F, and so forth and so on. And then we also have a fictitious end task at the end, which also has a processing time of 0. In the next few videos, we'll look at different ways that we can use project diagrams like this to make schedules and solve scheduling problems. Thank you for watching, and as always, I'm happy to help with any questions you have.